Hello everyone, I welcome you to the 6th lesson in the normal distribution. You know, I make these short lessons. I don't make it very long. I make 5-10 minutes, something like that. And that's the lesson. That's what I call lesson. So today I want to continue talking about finding probabilities involving negative values of Z. We had this situation last time. If you remember what we talked about last time, we were talking about finding the probability if you have a negative value of Z. And for a standard normal, the mean is 0, okay? The mean, the median, and the mode coincide, and that is 0. Now, what we want to talk about today, if you have an area on the negative side, and the area is between two negative values, this is negative B, and this is negative A. So you want to find the area between negative B and negative A. So what you do, like what we did last time, what you do, you transfer this area to the positive side of the normal curve, okay? The reason why we are transferring the area of the positive side of the normal curve is the standard normal tables read for Z values on the positive side. So if this is A and this is B, okay? And then what we do, we start the probability that negative A, negative B is less Z is less A is exactly the same as the probability, okay? That A is less Z is less B. Those are exactly the same. The probability negative B is less Z is less A is exactly the same as the probability of A less Z less B. For example, if I have an area between two negative values of Z, okay, I want to find the probability that minus 2.148 is less Z is less negative 1.44, okay? What I do, I transfer this to the positive side, you know. It is always good to do a sketch because you see what you are doing. So this is the probability that 1.44 is less Z is less 2.148. So let's sketch and see. Just the sketch helps us to figure out what we are doing without going off. You can even do without a sketch. So I want to have this probability right here. I will sketch 2 and I show you what I'm talking about here. Okay, that is a funny normal curve, but it's a normal curve anyway. Okay, so this is the 0 line. The normal curve will always be symmetric about the mean. So I have these two negative values, minus 2 point, I have negative 2.148, and also have a negative 1.44. So what I do, I transfer this area to the positive side. Unfortunately, I've done the reverse, but it is okay still. So I transfer this area to the positive side, and I have here 1.44, and then this is 2.148. So this area is exactly the same as this area. But because my standard normal tables cannot read the areas on the negative side because they are designed to read for values of Z on the positive side. So I will start the probability that minus 2.148 less Z less 1.44 is exactly the same as the probability from 1.44 less Z less 2.148. And then I go ahead and figure out, how do I find this probability? You know, tables will always, the standard normal table that I'm using reads from 0 up to a particular value on the positive side. So this is the probability at 0 is less Z less 2.148. Subtract the probability that 0 less Z less 1.44. Okay, and this is what I'm going to do. You know, I have, let me try to design two normal curves here. I use a different color. So I have here a normal curve, and then this is 0. So this is 2.148. So the table can read the whole area from 0 up to 2.148. Then I also have another normal curve right here, and this is the 0 line. Then this is 1.44. So the table can also read the probability from 0 up to 1.44. So if you want to get the area between the two Z values, okay? If I want to get the area between these two Z values here, what I do, I get the area from 0 to 1.44, okay? And subtract from the area between 0 and 2.148. So I got the normal tables, okay? And read what is the area between 0 and 2.148. So we have learned how to read the normal table. So we have 0 and then 2.148. 2.1 is right here, okay? 10, 11, 12, 13, 14. So that is 4838. Okay, yeah, so it is 4838, but I want 2.14, okay, and then 8. This is what I'm reading here, 2.148. So I have to move to the 8th column, go straight across and got the 8th column. So this is the first, the 8th column is going to be the second last, okay? If you move, this is the 8th column, and the value we're going to add is a 3. So if you add here 3, then that will be 11, then this will be a 4, this remains 8, this is a 4. So I have 0.4841, okay? So this is 0.4841 minus. So we go ahead and read for 1.44. 1.44, okay? 1.44, the area here is 1.44, 1.4, this 1.44, which is 4251. So I have 0.4251. So I subtract these two, okay? 0.4841 and then 0.42. Yeah, so just do the math, do the subtraction. You can use your head, you can use a calculator, you can use whatever you feel like, and then get this area, okay? 0.4841 minus 0.4251. Then you have the answer as 0.059. So this is 0.059. So that's the probability, okay? That negative 2.148 is less than Z is less than 1.44. And we have it, okay? So another situation I'm going to teach you will come in the second video. This is a short video. I intend to make it 10 minutes maximum so that when you're watching, it is always easy for you. Don't have to feel the burden. You know, if you know the time you're going to do something and then you start, sometimes you feel the burden and you don't read. So I make it a short video so everybody can enjoy it. Now, there is this other situation. It is normally written, the probability of magnitude of Z, okay, is less than an A, okay? This translates to the probability between Z lies between negative A and a positive A. Every time you have magnitude of Z is less, okay? So it means that if Z is negative, then you have a negative less than A, okay? If Z is a positive, then you have Z is less than A. So it translates to between minus A and a positive A. And on the graph, what you're going to do is to have something like this, and then this is 0, then this is a negative A, and this is a positive A, okay? So we want to find the area between negative A and a positive A. This is what we're talking about here, okay? And this area will be exactly equal to, okay, twice the probability between 0 less Z less A. Okay, it is exactly, you know, because we can use the normal curve, the standard normal, to read this area on the positive side. But this other area on the negative side from negative A to 0 is exactly the same as 0 to A. So what we do, we just double, you know, the area on the positive side, and that is it, okay? So if we are to find the area, okay, example, find the probability that the magnitude of Z is less than minus 1.4, okay, let me use 1.6 to 5, okay? That's what we want to find, that the magnitude of Z is less. So what we do, we say the probability that the magnitude of Z is less minus 1.625, okay? This is exactly the same as the probability, okay, from minus 1.625 less Z less 1.625. And then this is twice the probability between 0 less Z less 1.625. You just double the probability, okay, from 0 to 1.625. So what's that probability? Let's see. So you have 0, and then you have, this is what we're trying to find, between minus 1.625 to 1.625. And we want to get that area between, okay, this is the probability that the magnitude of Z is less than 1.625, okay? And how do we get it? Just read it. The probability that magnitude of Z, okay, is less 1.625 is now equal to twice the probability between 0 less Z less 1.625. So we got the normal tables and the rate. Okay, we have one normal tables here. So what's the probability that Z is 1.6? So 1.625. Let me read 1.625. 1.62 is right here. Okay, it is 44474. That's 1.62. And then we go and add on what's under, 5. So under 5, we have a 5. So we get a 5 and add it here. So 4 plus 5 is a 9, 7, this is 4. So we have 0.4479, okay? This will be 2 times 0.4479. Just double that probability. 2 times 0.4479, you get the answer as 0.8958. So we have learned how to read the probability between a negative value and a positive value, which are exactly the same in magnitude, okay? And that's how we write it. Magnitude of Z is less, okay? So the next part, I will talk about this as a situation. How do you find the probability that magnitude of Z is more than, okay, a particular value A? Okay, Andy, how do we interpret this? The interpretation is, this is the probability of minus A is less Z, okay? It is the probability, the best interpretation. I'm writing it wrongly. So it is Z less negative A, or it is the probability of Z more than A. So there are two areas here, okay? What we do, we get the probability of Z less minus A and add to the probability of Z more than A, okay? So this is it. You have, let me sketch the normal curve right here, and I show you what I'm talking about. This is 0, this is A, negative, and this is A, positive. So we want this area and this other area, okay? And there are so many ways of going about this, okay? You can say the area on the left-hand side is equal to the area on the right-hand side. And you say, okay, this is twice the probability between, twice the probability of Z is more than A. And how do we get it? Multiply it to 0.5 minus the probability of 0 less Z less A, okay? To find the area, this extreme area, we have the normal table right here, the normal curve. So this is A. And to find this part, what we do, we get the whole left half, which is 0.5, and subtract the area in blue, because that's what we can get from the logbook, okay? You can get that from the standard table. So this is equal to 1. it is equal to 1 minus twice the probability between 0 less a, less z, less a. So every time you have magnitude of z more than a, what you do, you get 1 minus twice the probability between z and a. Okay. So if I have a question here, find the probability that the magnitude of z is more than 1.002. Okay, 1.002. That's what I want to do. Find the probability, the magnitude of z. So this is going to be the probability of minus 1.0 minus the probability of, okay, let me change something here small. The probability of minus it is z less minus 1.002 plus the probability of z more than 1.002. Or you can say this is twice the probability of z. This is z more than 1.002, which is the same thing as 1 minus twice the probability of 0 less z less 1.002. So 1.002, okay, 1 minus twice this probability of 1.002, 1.00 is this, okay, which is 0.34. It is, I'll go ahead and erase some of these so I don't have to. Okay, let me see. I don't want to make a mistake like a mistake. Okay, this is okay. So I want 1.002. So what I do, I get 1.0 and then 0, which is 3. This is 0.3413. One 0.3413. Then I have to move to the second column in addition. Okay, there is a situation, the table comes and disconnects. So if you go to addition, you continue with it in the column of addition, don't go down. Okay, so this is under 2, we have a 5. So add here 5, and then you have 0.3418. So it is twice minus 3418. 1 minus 0.3418. So what you do, you go ahead and compute this, and that's the answer. Okay, 1 minus twice the probability. You don't have to rewrite a lot of steps because this can be done at this stage. We know you know how to compute 1 minus twice 0.3418. The answer is 0.3164. So that's how we deal with this type of inequalities, magnitude of z less than magnitude of z more than. That's how you go about it, and that is it. Yeah. So I believe you can now find probabilities. If you are given z values, you can find probabilities whether the values on the left-hand side, which are negatives, or right-hand side positive values. You can still go ahead and find the probabilities. Now we are going to start dealing with real situations. We want to move away from the standard normal and now look at any normal variable x. Okay,